Morning to you all. Let me start the class proper. So in today's class, we'll be just going over the worksheet the exercise that you were supposed to do in the last worksheet, and then we'll move on to the next topic. Okay, so we were on top-heavy graphs, top-heavy functions, sketching top-heavy graphs, and this was the question that you were supposed to do. It says our rational function is given by g of x equal to x square minus x minus 2 upon x plus 3. So you can see in the numerator you have x square minus x minus 2 and denominator is x plus 3. Now this is a top heavy function. Why? Because the numerator is heavy. And the highest power in the numerator says x squared. So highest power is 2. In the denominator it's only x. So the highest power is what? So numerator is heavy. So let's see how we can go about finding the x-intercept, y-intercept, then the oblique asymptote and the vertical asymptote. To find the x and y-intercepts, firstly x-intercept, you have to put the numerator equal to 0. That is x squared minus x minus 2 equal to 0. Now when you see what I have done it remember you have learned this in year 11, how to solve quadratic equations, right? How to factorize quadratic equations. This is type 1. Why? Because in front of x squared is 1, right? The coefficient of x squared is 1. If the coefficient of x squared was not 1, it was something else or more than 1, then it would have been type 2. So this is, since this is 1, and so our a is 1, b is -1, and c is -2. So what we have to do, we have to find the factors of this -2. That means two numbers that multiply to give -2, and same numbers should add to give you -1. That means factors of c that add to give you b. So the numbers we are getting is -2 and +1. Right? So that's how we got x minus 2 and x plus 1. If you'll expand this, you will get this back. If you expand x minus 2 and x plus 1, you'll get x squared minus x minus 2 again. Right? So what you do, just put x minus 2 equal to 0, plus 2 both sides, you'll get 2. Put x plus 1 equal to 0, minus 1 both sides, you get -1. So this is the x-intercept, -1, 0. This is another way to find the x-intercept. I think most of you have done that way using the quadratic formula. And remember, the quadratic formula is -b plus or minus root of b squared minus 4ac whole thing upon 2a. And you know a is 1, b is -1, c is -2. So you just substitute and you'll be getting these answers. Right? I hope you are clear on this. Then find the y-intercept. How you find the y-intercept? You'll have to use the whole equation. In place of x, you put 0, and you'll be getting -2. So answer will be 0, -2 upon 3. And most of you are clear on this, so I don't have to show a detailed working. Next one, find the equation of vertical asymptote. Now to find the vertical asymptote, you have to put denominator equal to 0, which is x plus 3. So put x plus 3 equal to 0, 3. Then minus 3 both sides, you'll get -3. Then comes the oblique asymptote. Now oblique asymptote, you have to use the long division. So this is how we have done it. See, x squared minus x minus 2. Right? This one is divided by x plus 3. So a number times x should give you x squared. So that number is x. X times x is x squared. So we wrote x squared here. Then the same number, same x, you multiply with this 3. X times +3, you get +3x. Once you are done with that, you just rule off and then put the minus sign. Then subtract. X squared minus x squared is 0. So I have not written anything. X squared minus x squared is 0. negative x minus positive 3x is negative 4x. See, it's negative 4x here, and then this negative 2 that was left on top, it came down here. Right? So we are left with negative 4x minus 2. Now, from here, we have to choose another number, a number that can multiply with x to give you negative 4x. And that number is negative 4. Negative 4 times x is negative 4x. I have written it here. And the same number you multiply with this 3, and that answer will come here. Meaning, negative 4 times positive 3 is negative 12. And then you subtract negative 4x minus 4x is 0. And then negative 2 minus negative 12 is positive 10. So this 10 is the remainder. So you don't have to worry about the remainder. Your answer will be y, because we have to find the equation only. So answer will be y is equal to x minus 4. Y is equal to x minus 4. This is what you have to do in part C. Part C says determine the equation of the oblique asymptote. It doesn't say find the x and the y intercept of the oblique asymptote. Just have to find the equation. So equation is y is equal to x minus 4. Now in part D, it says sketch the graph of the function. Now in order to sketch the graph of the function, you have to find the x and y intercept of this oblique asymptote. So that's what I have done here. See, to find the x-intercept, this was our equation. To find the x-intercept, put y is equal to 0. In place of y, put 0, 0 x minus 4. Answer will be positive 4. So 4 comma 0 is the x-intercept. To find the y-intercept of the oblique asymptote, put x equal to 0. So in place of x, put 0, y equal to 0 minus 4. Answer is negative 4. So it's 0 comma negative 4. That's the coordinate. Okay. So these are the two coordinates for oblique asymptote. Now once we are done with that, then we go and see how we can sketch the graph. Now this is how our graph looks like. Now let me show you the x-intercepts and y-intercepts. Right? Remember our x-intercept was negative 1 and 2. So see, it's negative 1, 0 and 2, 0. These are the x-intercepts. Right? You just plot these points and wait. Don't sketch the graph. And then we have to put the y-intercept. What was our y-intercept? It was 0 comma negative 2/3. So 0 comma negative 2/3 is here. Sorry, I think I missed it. 0 comma negative 2/3 is here, right, at this point. So this is our y-intercept. And then we have to go to the asymptotes. Asymptote, the vertical asymptote was x to negative 3. And then oblique asymptote, you know, is has two coordinates, x and y intercept. The x intercept is 4, 0 and y intercept is negative 4, 0. Now I have seen some mistakes. Some of you have drawn it the other way. You found the calculation is correct, but the graph is wrong. So please note 4, 0 will lie here, right? And then 0, negative 4 will lie here, right? So those are the intercepts of the oblique asymptote. Once you are done with that, you draw a dotted line, right? So once you can see the dotted line, then you will know how your graph will look like. Then you go about sketching this graph, right? Like this, through this point, through the y-intercept, through this x-intercept, and go up and parallel to this asymptote. Okay? And the graph will be down here, right, at the bottom. Right? Most of you got it correct. I have marked your work, but those people who got it wrong, please now try to understand how to go about sketching the top heavy function graph. Right? Okay, now I'll move on to the next topic now. Right, we are done with sketching graphs of rational functions. Now our next topic is limits. Yeah, limits is something you have done last year, so I'll go over it again. And let me just show you people some important concepts in limits. Now to calculate limits, remember to find limits of rational algebraic expressions, directly substitute in the expression. So you have to find limit of anything, whatever number is, please substitute and check whether getting an answer or not. So if upon substitution, right, if you get I upon b, that means a number upon another number, then that means that is a limit. For example, if you're getting half, or you're getting 3/4, or any other, or 3 upon 8, or 1/3, that means that is the answer, that is the limit, right? But if you are getting 0 upon a number, for example 0.2 or 0.3 or 0.5, 0.10, right, that means limit is 0, because 0 divided by any number is 0, right? So limit will be 0. Now if you are getting a number upon 0, you're getting a number upon 0, that means 0 is in the denominator, right? If you're getting that, that means limit does not exist, because if you in the calculator any number divided by 0, 1 divided by 0, 2 divided by 0, 10 divided by 0, 100 divided by 0, any number divided by 0, you will get undefined, right, a maths error, right? So that means limit will not exist. Now next one, if you are getting 0.0, there are situations where you get 0.0, right? If you're getting that, that means limit will exist, but you have to further factorize, cancel and substitute, right? That means you have to do some factorization in the numerator or denominator and cancel some things, right, common things from numerator and denominator, and then substitute, right? Then you will see that the limit, then you will be able to find the limit, right? Now first one, limit as x approaches 0 sine x. Now as I said, if you get this type of questions, it's very easy, just substitute the value that it is approaching. Now our limit is approaching the x value of 0, so just take this 0 and substitute in place of x here, okay? See, instead of x I have substituted 0, so sine 0, if you press in the calculator you will get 0. If you are getting 0 only, that means that is the answer, 0 is the answer, okay? You are not getting 0 over 0 here, remember that, okay? There is no denominator here, you are getting just 0, so that means limit is 0, right? Now next one, if you have something like this, limit as x approaches -3. Now instead of x put -3, instead of x put -3. So when you substitute, you can see -3 plus 3 is 0, 0 in the numerator, but in the denominator you're getting -5. So 0 divided by any other number will give you 0, right? 0 divided by any other number will give you 0. You can just press in the calculator, you'll see. So answer is 0, right? Limit is 0. Next one, if you have something like this, x squared plus 4x plus 3 upon x minus 2. Now directly substitute, again you will see when you put 2 in place of x, 2 squared is 4, 4 2 is 8 plus 3, so 4 plus 8 plus 3 is 15, 15, and 2 minus 2 is 0, so a number upon 0. Now since there is a number upon 0, if you put this in calculator you will see a math, right? That means limit does not exist. See, I have shown you people 3 scenarios, right? One is a number, you're getting a number only, that's okay, that's the first one. Second one, you're getting a 0 upon a number, right? That means limit exists, answer is 0. Third one, you're getting a number upon 0, that means limit does not exist. Now fourth one, let me show you. I think this is not in the worksheet that was given to you. It says limit as x approaches 1, 1 minus x squared upon 1 minus x. Now, instead of x, you have to put 1. When you put 1, you will see 1 minus 1 squared is 0, and then 1 minus 1 is 0. So, you're getting 0 upon 0. Now, remember what I said before, right? If you're getting 0 upon 0, right, limit will exist. But what you have to do, you factorize and substitute the x value again. So we have to factorize, we have to simplify, right? So let me show you. Now, there are two methods. One method is you use the L'Hopital rule. L'Hopital rule means you use differentiation. Right? Differentiation is again something you have learned last year. Right? Differentiation, the rule steps is bring the power in front and minus 1 from the power. So what you have to do, this is one method. I'll show another method after this. What you have to do, you just differentiate the numerator and differentiate the denominator. In the numerator, you can see you have 1 minus x squared. When you differentiate 1, you're getting 0, nothing. So that's why nothing is written here. See, I don't have. Now, when you differentiate negative x squared, you bring this 2 in front, you get negative 2x, and then minus 1 from the power. So negative x squared, when you differentiate, you will get negative 2x. Right? So numerator is done. Then you differentiate the denominator. In the denominator, you have 1 minus x. When you differentiate 1, you'll get 0. And then when you will differentiate negative x, remember the power of x is 1. Bring this 1 in front, it will be negative 1x. Then minus 1 from the power, 1 minus 1 will be 0, you'll get x power 0. So x power 0 is 1. Any number to the power 0 is 1. So that 1 times negative 1 will give you negative 1. So remember, when you differentiate negative x, you get negative 1. You have done this last year. Please go and refresh your mind, check in your notes, last year's notes, or also you can check in our textbook. Or if you still don't understand, go to YouTube and see how it is there. How do you differentiate functions, right? So just differentiate the numerator, and then once you're done with that, then you substitute. Instead of x, you put 1. So you can see instead of x, 1 is put, right? So negative 2 times 1, get negative 2, and then negative 1 is already down there. So negative 2 divided by negative 1, you get positive 2. Answer is 2. See, in the beginning, we were getting 0 upon 0. Now, after using L'Hopital rule, after differentiating, we're getting 2. Okay? That was one method. Okay? Second method is you what you do is simplify. Okay? How can you simplify? Remember, in the numerator, you can see a 1 minus x squared. 1 minus x squared. Right? You can use difference of 2 squared. Difference 2 squares means I squared minus b squared is equal to I plus b, I minus b. I always tell that in the class. Right? So remember, this is 1 squared minus x squared. So 1 squared minus x squared is 1 plus x, 1 minus x. That's how we got it. Okay? 1 squared minus x squared is 1 plus x, 1 minus x. And in the numerator, you have 1 minus x. So 1 minus x and 1 minus x will cancel, and you will be left with 1 plus x in the numerator. Okay? So once you got this, now instead of x, you put 1. Now you put 1, 1 plus 1 will be 2. See, using both methods, we are getting the same answer. Okay? 2 here, 2 here. Right? This was L'Hopital rule. Method 2 was using factorization method by simplifying. Okay, I hope you are clear on this. Now, if you're not clear on this, let me just show you one small video. I think it's 4 minutes video. Please see and listen very carefully. Sorry.
In the general sense, limits limits allow us to determine what value a function is approaching and use it to create a limit. Not necessarily what the function will give us as an output, but rather what value it's getting arbitrarily close to. Let's explain limits using an analogy. Suppose you are watching TV and start getting a massive craving for pizza. Fortunately, you just happen to have some leftover pizza in the kitchen. So you get it from the couch and start heading towards the fridge. In this instance, if someone were to describe where you are going, they would say you are approaching the fridge. In their description, because as you keep walking, you are getting closer and closer to where the fridge is located. This example is the same thing we want to do with functions. When we take the limit of a function, we are describing where they are going. Let's see an example of this with the function 3x squared minus 1. With this function, I'm really curious what value the function is approaching as I use x values close to the number 2. Let's see this by using something like 1.9, 1.99, 1.999. When I use these, I get values such as 9.83, 10.8803, and 10.9003. From these values, it appears that the function is approaching 11. So we say that the limit of the function as x approaches 2 is 11. Remember, what I'm really saying here is that we can get arbitrarily close to the number 11. I just have to pick values that are sufficiently close to 2 to do it. Now at this point you might be thinking, that's fantastic. Couldn't you have also found the limit simply by plugging 2 into the function? Wouldn't that also give you 11? In this instance, the answer is yes. But the focus with the limit should be on what value it's approaching, and there are some functions where we simply can't plug in a number to find the limit. In other words, they're not always the same. Let's cover this by going back to our pizza analogy. Like before, we've been struck with a craving for pizza. So you were headed towards the fridge for a quick snack. Now, in one scenario, the fridge is there, loaded with pizza, and you can easily satisfy your craving for pepperoni. But in an alternate scenario, the fridge is gone, possibly stolen by pizza-craving ninjas, and you are left empty-handed. Even though both of these situations are completely different, your behavior leading up to them is exactly the same. In either case, you are still approaching the fridge. This is the key difference with limits. They are used to describe what value a function is approaching, but they are not used to value the function actually reaches. Let's see how this works with yet another function. Let's go ahead and use x squared minus 4 all divided by x minus 2. Like before, we are interested in what value the function approaches as we use x values close to 2. Let's go ahead and choose something like 1.999. When we use these, we get values of 3.9, 3.99, and 3.999. From these, it appears that the function is approaching 4. So again, we say that the limit of the function as x approaches 2 is 4. If you try and find this value by instead plugging into, something strange happens. When you plug 2 into the function, you get 0 divided by 0. This shows that the function doesn't actually ever get to 4. In fact, a quick look at the graph shows a hole right where 4 is. Despite the hole, the behavior of the function leading up to it is the same. Since the behavior is the same, we still say that the limit of the function as x approaches 2 is 4, even though it never actually gets there. Hopefully both of these examples really highlight how limits focus on the behavior of a function, what they get arbitrarily close to. One thing we still have left to cover is what it exactly means when we say that a function gets arbitrarily close to a value. But don't worry, we'll be able to tackle that tricky problem in the next video when we introduce epsilon and delta. Thanks for watching.